Hello, this is Ocean Iron Fertilization. It's by Juliana Thompson-Williams.
Abata.
Sara Eley.
And Kieron Schmitt.
So, what is ocean iron fertilization? It's a geoengineering technique that adds small amounts of iron to the ocean to remove carbon dioxide from the atmosphere. It is slow acting, inexpensive, and is based off the ocean's natural processes. So, how does it work? The main concept is that the more iron you have, the less CO2 there is. And that concept only works through phytoplankton. Phytoplankton are photosynthetic marine microorganisms that float on the ocean surface, and they convert CO2 from the atmosphere into oxygen in food. And by doing this, having more phytoplankton can remove more carbon dioxide. In order to have more phytoplankton, we have to add iron to the ocean, as that is a key nutrient for the phytoplankton.
Some examples and limitations. Ocean iron fertilization happens. The first is ship-based deployments. Scientists have conducted experiments where ships release iron sulfate directly into iron-poor parts of the ocean. The second is natural fertilization. For example, wind-blown dust from the Sahara Desert travels thousands of miles, naturally fertilizes the Atlantic Ocean, and volcanic ash can also add iron. However, there are major limitations. Ocean iron fertilization can negatively affect marine food webs. It cause nutrient robbing, promote harmful algal blooms, or contribute to oxygen depletion as large blooms decompose. These risks highlight why ocean iron fertilization is still controversial and requires careful monitoring.
Why is it important? Ocean iron fertilization is being studied because it could help remove carbon from the atmosphere by stimulating phytoplankton. CO2 is absorbed through photosynthesis. Two, boost productivity in nutrient limited regions. Iron poor areas could see increases in biological activity and support marine food webs. And three, serve as a potential climate solution. If ecological risks can be managed, OIF could become a cost-effective carbon sequestration strategy, but much more research is needed.
Okay, so for the current state of iron fertilization, um, there have been uses on a small scale, but nothing has shown any reliable long-term carbon sequestration, um, just byproducts. Research-wise, there's a lot of ecological risks at play, which still need to be researched before we can implement on a larger scale, such as, like habitat loss. Current research is small, isolated, in control areas, so no wide-scale uses yet. Policy, there's just not much policy trying to support large-scale ocean fertilization because there's just too much uncertainty. And current developments, research is being focused on minimizing risk and finding if there's any environmental systems like um, pluses or minuses in relation to OIF. Search sources, and then the end.
Sarah